Hey everybody, Mr. Quick here. We're going to be looking today at Eureka Math / Engaged New York Math, Module 3, Lesson 19, Problem Solving on the Coordinate Plane. Now we're going to take our coordinate plane knowledge that we've gained. We know how to create points. We know how to move down, up and down the plane, whether it's going negative to positive, positive to negative, going higher on a positive scale, lower on a negative scale, whatever it may be. We learned how to move around on the coordinate plane, but now we're going to use the coordinate plane to solve some problems. So let's go ahead and jump right into it because I have several examples I'd like to go through. Okay, we've got two slides here I'm going to show you. This one is obviously a coordinate plane, and this one has some questions. So I'm going to read the questions, and then I'm going to work on the coordinate plane to show you what I'm doing here. It says locate and label these ordered pairs 4, 5, and 4, -3. Draw the line segment between the endpoints on the coordinate plane. How long is the line segment that you drew? Explain. Okay, well, first thing I'm going to do is I'm going to find 4, 5, so that's over 4, up 5. I'm going to mark that. Then 4, -3. So I'm going over 4, I'm going down 3. I'm going to try to get this as perfect as I can. It's hard to do it on the iPad here. So how long is the line segment? So they want us to draw the line segment in between, right? So we're going to go 1, 2, 3. 1, 2, 3, 4, 5, right? Absolute value here is 5. Absolute value here is 3. So the distance between the two would be 8, right? We could count them up, or we could say, you know, what is the absolute value of 5, absolute value of -3? You'd get 5 and 3. You add them up. It's 8 units. We say units because we don't know how big these actually are, right? That could represent feet, miles, inches, so we just say units. Draw a horizontal line segment starting at 4, -3 that has a length of 9 units. What are the possible coordinates and other endpoint of the line segment? There's more than one answer. All right, so it's saying if we're going to start at 4, -3, which is right here, and it wants us to draw a horizontal line segment that is 9 units long. So horizontal goes side to side. You think about like a picture that you might draw, like the sun setting or the road coming to a point. This line is called the horizon. So when you think of horizontal, think about the horizon. Vertical is up and down, right? So you might think about a basketball player going to dunk the basketball. Has a really high vertical, they might say a vertical leap, so they're going up and down. So we can go 9 spots out, so we can go 1, whoops, sorry, I had on my eraser, I didn't realize I had that. We could go 1, 2, 3, 4, 5, 6, 7, 8, 9. So we could come all the way out here, in which case we would be going 13, -3. So that's one possible answer. Or we could go back 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, in which case our answer would be -5, -3. So either one, right? Which point did you choose to be the other end of the horizontal line segment? Explain how you chose that point. Well, it doesn't really matter. We'll just go ahead and go with, we'll go backwards. And the only reason I'm choosing that point is I think we're going to do more with this. I've looked ahead a little bit, so we want to have more room to work, right? What do you notice about this? One of the things that I notice is that this appears to be a 90-degree angle, or a right angle. And I'm looking at some possible shapes that we can make out of this. So I'm not going to write all that down, but that's kind of my explanation there. But let's go ahead and go forward and see what else they're going to want us to do with this. Okay, the two line segments that you have just drawn could be seen as two sides of a rectangle. Given this, the endpoints of the two line segments would be 3 of the vertices on the rectangle. So what they're saying is, there's a vertices, here's a vertices, here's a vertices, right? Like you could kind of almost imagine filling in the rest of the rectangle here. So you see, you know, a partial shape. Find the coordinates of the fourth vertex of the rectangle. Explain how you find the coordinates on the fourth vertex using absolute value. Well, so what we're looking at here then is if we were going to finish this rectangle, where would that last vertex? Vertex is where two lines meet, by the way. So the corners. Where would that last one be? Well, we know that it would have to be as far back as this one, right? Because we've all seen a vertical what am I trying to say? We've all seen a rectangle, so it'd have to be as far back as this point. So it would have to be -5, and it would have to be as high up as this one, right? So just using those two spots, we know it's going to be -5, 5. We can fill that in, and then if we were to fill in the rest of the lines there you go. It looks almost like a square, but it's one space long, so they're not all equal sides, but it's close. So it's a rectangle. Find the coordinates of the fourth vertex of the rectangle. How did you find it using absolute value? Well, basically two things. One, it is -5, 5. And if you wanted to use, so I just looked at the fact that we are back 5, so I knew that we had to go back 5 spaces, and that we are up 5, so we had to go up 5 spaces. You could also look and see how far back from this spot, or this point is, using absolute value, and then you could have just gone back this way and made your point. Either way, right, you're going to get to the same answer. Okay. Construct a rectangle on the coordinate plane that satisfies each of the criteria below. Identify the coordinate of each of its vertices. Each of the vertices lies in a different quadrant. So I know my rectangle has to have a spot in each quadrant. I don't know where those are going to be yet, but I know I have to have one in each. I can't do a rectangle like up here, right? I've got to do something that'll look sort of like that. So its sides are either vertical or horizontal. So nothing like this, right, where it's like at an angle. Like we're going to follow the lines as we know them currently. And the perimeter of the rectangle is 28 units. Perimeter meaning going around the outside of the rectangle. So that's the first thing I'm going to look at, is knowing that the perimeter is 28 units. So each spot, like 1, 2, 3, 4, those are units. So what I need to do then is say, okay, my perimeter is 28. So, and I have 4 sides. Now you might think, well, divide it by 4, and then you just do 7 sides on each, right? Can't do it that way. It doesn't work that way. Because if they're each 7 sides, you don't have a rectangle, you've got a square. Now, what I'm going to do maybe here is I'm going to, since I know it can't be 7, because I don't want them to be equal, I might do one that's 8. And so I'm just going to start here. And that's -5, so to get to 8, I'm going to go to +3, right? Because -5 to 0 is 5 spaces, 0 to 3 is 3 spaces. So if I can make that line a little bit better. So I have 8 spaces here. Now if I know I'm going to have 8 spaces on the other side, I just don't know where it is, I'm going to write that 8, 16, right? So I already have, wherever my other side is, I don't know where it's going to be quite yet, because I don't know what this side is going to be, how far that's going to be down. But I know I currently have 16 spaces filled. If there are 28 total, 28 minus 16 is 12. So then my other 2 sides have to be 12 combined. So there's 2 sides left. 12 divided by 2 is 6. So I know I'm going to go down 6. So I'm going to go down 1, and then I'm going to go down 5. Because of using absolute value, I know that that is 6 spaces, right? +1 is 1, -5, absolute value is 5, 5 and 1 is 6. Same thing here, I'm going to go down to -5 here. So I know that's a 6, that side is 6, that side is 6. I'm going to go over, and I've got my 8 there. 8, 16, 22, 28. There's my rectangle. Is there vertices in each quadrant? There is, right? This is in quadrant 1, quadrant 2, quadrant 3, quadrant 4. Its sides are vertical or horizontal. That's correct, right? Meaning they all go this way or they all go this way. They do. Perimeter is 28. Well, we made sure that the perimeter is 28, so we're good to go there. And then using absolute value to show the lengths of your rectangle provide a perimeter of 28. We did that as well. So, having said that, there's our shape. Okay, this is a different question, and we were going to create another one. I don't think I'm going to have time to do that, but I'm going to use the rectangle that we just created to answer these questions. So, what is the perimeter of the rectangle? Well, we just said it's 28 units, right? Because if you counted just the outside, you know, this goes up and down 6, this goes across 8, 6, 8, there you go. You add all those together, you get 28 units. What is the area of the rectangle? Well, area is length times width for area. So we have 6 times 8, which is 48. So we have 48 units squared, because it's area, right? Now it says draw a diagonal line through the rectangle with opposite vertices for endpoints. What geometric figures are formed? So if let's pick this vertices. Here, I'm going to use a different color. Let's use blue. We're going to use this vertices and this vertices. We draw a diagonal line, and it won't be a perfect line, but I'll do my best. Down the center, what two shapes did we just create? This is what geometric figures, so that's basically I'm asking what shapes. Well, we've got, hopefully you see this, I'll outline it with my orange here. You've got a triangle here, and you have a triangle here. So we just created 2 triangles. Next part of the question, what are the areas of these 2 figures? Well, here's the trick there. We know the area of the rectangle is 48. This line just cut it in half. So the area of this triangle is going to be half of 48, which is 24, right? 48 divided by 2 is 24. And then this half will also be 24 units squared. So, having said all that, and by the way, you know units squared, like if I create that, like you see that all these squares are the units and they're squares. See how that works? That's why we say units squared. Having said all that, that's a lot to throw at you, but we're going to talk more in depth about this in class, but I just wanted you to have something you could go back and reference and check this out and kind of see some of the different things that we did, some of the different ways to do it. We'll talk more about this in class. Thanks for watching. See you later.